Good afternoon, ladies and gentlemen. A very warm welcome to all of you for joining us today for this exclusive digital dialogue on predictive intelligence for industrial enterprises. This session is powered by Advantech and Nagarro. As you know, Advantech is a leader in IoT intelligent systems and embedded platforms, while Nagarro is a digital engineering leader enabling organizations to become innovative, agile, and digital fast. Today's discussion will explore how predictive intelligence is transforming industrial enterprises, and we are joined by an exceptional panel of experts today. So from Nagarro, we have Mr. Tanuj Chawla, who is the principal consultant for Smart Factory. Then we have again also from Nagarro, Tushar Gulati, who is the associate director for Industry 4.0. Representing Advantech India, we have Praveen Salvi, who is the technical manager. Mr. Mohit Kumabat, IIoT Sales Director at Advantech India. And we are excited to have such a distinguished panel with us today and look forward to an engaging and insightful discussion. So let's get started. So let's begin with the discussion with a brief presentation by Mr. Mohit Kumabat. Welcome, Mohit.
So basically, Advantech founded in 1983 with a vision of enabling an intelligent planet. And 2025 revenue for Advantech is 2.27 billion US dollars, with a worldwide employee strength of 8,900 people. And basically, we are serving worldwide IoT solution system integrators and global system houses in the field of Industry 4.0, Industry IoT, embedded computing, is smart city, which includes healthcare, retail, and logistics. To support our global customers and big system houses worldwide, we have three manufacturing sites located in China, Japan, and Taiwan. Here are some of the global awards and honor for Advantech. Now, I would like to hand over to Shar, who will share in detail about challenges in industry and how we overcome from the challenges by implementing solution developed by Nagarro.
So, before moving further, let me quickly give a glimpse of who we are and what we do. So, Nagarro is a global digital engineering and technology services leader listed on Frankfurt Stock Exchange with a revenue nearing 1 billion euros. We are present in more than 39 countries with 18,000 plus employees, serving more than 1,000 clients globally. So, now what exactly is predictive maintenance? In simple words, predictive intelligence uses historical data, uses real time data, and advanced analytics, often powered by AI or machine learning, to predict and forecast what is likely to happen in the future and enable timely action. So, industry leaders and executives reported that AI enabled predictive maintenance can reduce unplanned downtime by 20 to 40% and lower total cost of ownership by approximately 10% when scaled. More than 90% of organizations that have implemented predictive maintenance, they have reported a positive return on investment, with many achieving payback in under 1 year. In many of the asset heavy industries, predictive maintenance has also been shown to reduce planned maintenance work by up to 80% while improving reliability and profitability. Now, in order to enable predictive intelligence, definitely we first need to have a strong and scalable data foundation. And this is exactly where Nagarro helps. So, at Nagarro, we see industrial transformation as a maturity journey, starting from basic computerization and connectivity to visibility and transparency, and eventually up to prediction and autonomous systems. Let's explore what is CIOTA and how it helps create a data foundation. CIOTA is a suite of 30 plus accelerators that orchestrate the entire data journey, starting from machines and sensors on the shop floors to asset onboarding and edge computing, up to data processing, analytics, and visualization on the cloud. These accelerators are designed to reduce time to market, decrease total cost of ownership, and facilitate rapid prototyping. It is device agnostic, cloud agnostic, secure, and aligned to unified namespace principles. Now, using CIOTA, we can onboard assets quickly, contextualize, normalize data, make it ready for advanced analytics, and create a very strong data foundation. Once we have built the data foundation now, the next question is how do or how can I achieve the predictive maintenance use case? This is where our second accelerator suite comes in. That's CPI. We call it as cluster of predictive intelligence accelerators that integrate with CIOTA or any other platform that you may have and enables predictive intelligence use cases, including predictive maintenance. It helps businesses detect real time anomalies in equipment or operations, forecast events, and even optimize operations as well as resources. The underlying CPI framework supports building, configuring, and retraining AI ML models on real time basis, helping improve accuracy and reliability over time. In terms of use cases, it supports a wide range of applications such as predictive maintenance, anomaly detection, process optimization, and so on and so forth. With this, I hand over to my colleague Tushar to further walk you through the live demonstration.
Hi, hello everyone. I am Tushar Gulhati and I am an Industry 4.0 evangelist and I've been working with such implementations for over a decade. What you see on the screen is a demo setup that we have, and this demo setup is also in the lab. Um, you would see that with the name of CPI demo station as an attendee on this list. What you see on the screen is a motor bearing assembly. This is analogous to any industrial asset that you would have in a factory or in the field. This is connected to a bearing and an eccentric load. The data from the motor is flowing to a variable frequency drive. So you see it as a VFD marked. The VFD is sending data to a PLC. We are using Advantech PLCs and servers. We'll be talking about that in a little bit. We are also using an HMI from Advantech where we are showcasing different trends and patterns that are being captured from the motor. All this data is being captured through the edge gateway, which is doing the further computing and sending it to the cloud. What you see here is also an eccentric load ring. This is a load ring where we are going to be simulating the load onto the motor. This load will create eccentricity on the motor and create vibration and noise. And that's what we are going to show you as a demonstration today.
As Tushar has already explained you the flow, so let me just go through quickly. So right now you can see the motor and some sensors. In motor, we will just calculate the RPM, then vibration and temperature with the help of iOS. We are using in this demonstration drive. So the red color you can see these are our Advantech products. So the first product is MX5570, which will act as a PLC. It supports codices as well as multiple IOs. With the help of codices, you can do your programming as per your requirement, and it supports also various types of protocol like Modbus, Profinet, Ethernet, IP. So we can convert it into the any kind of protocol. So the next product which we are using for this specific demo is WebOP207K HMI. So we can just monitor this data with the help of Modbus. Again, on the right hand side, you can see the edge gateway, which can be used for the connectivity between two different protocols like Modbus to MQTT or OPCUA. MX5570 supports OPCUA protocol, so that can be directly connected with the UNO 2484 for server PC, which will act as a server PC. And it has a Wi-Fi connectivity, so we can connect it with the 5G router. And that analytics will be run on Nagarro CPI system. Let's talk about the hardware which we are using for this specific demo. that is UNO 2484G, and you can see the specification like CPU, which supports i3, i5, i7. It has expansion slot M.2, then 2 mini PCI slots, TPM 2.0 support for hardware security, and operating temperature from -20 degree to 60 degree. It has a LAN ports, HDMI port, iDoor model support, and 4 COM ports. Let's move on the next product which we are using for this demo. That is MIC 770. So we do have a various types of form factor. Right now you can see, and it can be used for various application, and it is a fanless box computer. And also we can use AIIS for machine vision application. Now let's talk about the product which we are using for this specific application, MIC 770. So it is a ruggedized, compact and fanless design, support wise DC input. It has various types of processor support from Atom, i7, Xeon, and it has a modular design, so you can, it will be flexible for various types of application. And it can be customized with 20 standard PCI lanes for IO customization and expansion. So that's all from my side. Thank you. Now I would like to hand over this to Mr. Tushar, who will do a live demonstration.
So, like we had discussed, what you see on the screen, on my screen is an actual demo setup. We have a motor that's connected to a coupler, and we have a eccentric load on the right hand side. All the data flows to the cloud. CIOTA as a data platform is comprising of two parts. One part sits on the edge gateway, and the second part is sits on the cloud. We will now talk about the application itself. So let me show you the application really quickly. What you see on the screen is a module which we call as digital twin module of CIOTA. CIOTA in itself is an IoT platform. There are many features which I'll be showcasing to you, but let's dive into the use case of predictive maintenance directly. So I'm going to showcase how this asset is now controllable. So what you see on the screen is a digital twin of a bottling line, and this conveyor is being powered through this motor, and this particular motor is linked in the background with the actual asset. I'm going to be starting this motor now, and what you will see is it says the command is triggered successfully. As soon as that happens, you also see that the motor speed starts increasing. I had preset RPM of 68%. You see the vibration comes up to 2.11 mm per second. There is a temperature value, there is an acoustic value, and we start seeing real-time graphs, and you will see the motor as well moving on the screen, right? What you also see here as part of the real-time graphs would be the risk score and the speed and vibration values in real time. All of these values, as you can see, denote how the asset is performing. Let's dive deeper into what actually is going on in the background, right? So we will now quickly switch off the motor, and I will request my colleague to introduce an eccentric load, a small eccentric load onto the motor through this load ring. What this will do is it will increase the vibration and the noise on the motor. I'm going to start the motor again. And as you can see, the motor is rotating. We can also see it in the real time, how the anomalies are getting detected for this particular asset in real time. Right. Let's increase the load furthermore. This is right now at a state where it is unnoticeable by the human, but there is a machine learning model in the system which is able to identify these changes and identify such patterns. My colleague is now changing the eccentric load again on the motor, and you can see the speed on the motor has gone down to 0. We are also able to see the risk score was about 63 and a moderate risk score. I'll start the motor again, and now the vibration goes excessively high. started rotating, and you will see there's a lot of vibration on the right hand side. There'll be a lot of noise on this motor now. It comes to a point where it becomes unbearable. You see the risk score on the motor is has increased to 73.5. There is a continuous anomaly that has been triggered onto it, and what we are also able to now know whether there may be a failure, right? So let's check the alerts and we will be able to know more. So you see there is a warning that is created. It says there is a motor which is linked to a particular asset. There is a hierarchy. We're using ISA 95 as the template. There is a risk score of 70.5. It says there is a 96.3% contribution that vibration is the reason why this anomalous behavior is happening. We can also mark this anomaly as true or false, right? I can say that, maybe, hey, machine learning model, you did not probably identify it correctly, and I can mark it false, and a model will basically learn from it. I can update images, and this is called the reinforcement learning concept, where the human is put in the loop. So if I want to dive deeper into this, right? So let's assume that, so we run the test for last 10 minutes, and I will essentially be looking at the last 10 minutes data for this particular motor. What I know is there is an average risk score of 68.47. There was a point when the risk score went to 87. This was that point. I know that vibration was the highest contributor to the entire anomalous behavior that the motor is having. Right? We also know what type of different alerts came during this period. And were they anomaly alerts or were they failure alerts? What was my distribution in this entire period for the alerts? Which contributor played the highest role in that distribution? Was the alert an alert of moderate risk or a high risk? Right? So we have a lot of these type of properties which tell what may be happening. What would be the first step? You would have either a new customer or you would have a factory. Here we have multiple different factories that are set up. You can add users to this factory. If I'm the plant administrator, this will be the first default screen that I will have, which will be for the dashboard. I will be knowing what edge gateways are online and which are not. I will know what are the different data sources that exist. What's better is I show you an asset hierarchy view. You will have an entire view of your factory in one pane. Right? So it says Nagarro as a factory, Gurgaon as a site, and you may have multiple other sites, multiple other zones, lines, and units under it. What's better is you can even go and add new units at your own convenience. Now, let's say I introduce a new machine tomorrow, right? How easy is it to onboard a new machine? So you can see here, I have labeled the machine to a particular hierarchy, and that machine has a particular data source and a machine property list. So what you see here is a data source, which was the OPCS server, which we were talking about earlier. There are different properties that are linked to this. You can have as many properties and you can create as many properties. In fact, some properties may be inherited properties from the particular motor, like we had shown, which is, for example, the acoustic property or the speed or the RPM, right? And some properties become derived properties. So you maybe have like a current and you have a current and a power, and you want to basically derive some properties out of it, right? So you would be able to do that, and with that you will be able to derive a new property which may be power. So there is scalability with respect to the devices that you want to connect to. There is scalability with respect to factories that you want to expand to, and there is scalability with respect to new properties or new type of inherited properties that you want to connect. What's more, we also have different features that we offer as part of alerts. So we were able to see different type of alerts that we have. For example, the threshold alerts and email alerts. So all of these can be very easily configured for a particular machine. I can say that these alerts should be sent to this particular user, and this particular user should be receiving these type of alerts, and I can add those users and they will get the emails on those alerts. What I would also like to show is the dashboard module that you had seen earlier. This is very configurable in the respect that you can add any widget of your desire and you can give a name to that widget. You can choose different properties for that widget from the entire hierarchy. So this is a configurable and a personalized dashboard that you have, and you can design the dashboard at your will and at your pace, right? The way you like, so that you see what you want to see. What we also offer is different kind of historical analysis on the motor itself, where you may be able to identify different you may be able to identify different type of load conditions on the motor and be able to read what went wrong. And with this data, you will be able to dive deeper into any type of problem that happened during a particular time period, right? And you can also export reports. You can export URLs that can be copied, and you can populate dashboards on Power BI as well. So, like I mentioned, predictive maintenance is not about one asset. It should be done for critical machinery. CIOTA and CPI offer you an entire repository of accelerators that can help you in data acquisition, storage, processing, analytics, and different models that help you scale this operation across machines. We have different type of models starting from the point of anomaly detection to failure prediction and finally being able to identify how much is the life of my asset left. I hope this demo was useful to you.
Thank you so much, Tusar, for that fantastic presentation and helping us to understand, how the shift from reactive to predictive operations can help organizations enhance efficiency, reduce downtime, and make smarter data-driven decisions. Thank you so much for that. And so, as we wrap up today's Mojo for Industry digital dialogue on predictive intelligence for industrial enterprises powered by Advantech and Nagarro, I would like to thank our esteemed speaker today, Mr. Tanuj Chawla, Mr. Tushar Gulati, Mr. Praveen Salvi, and Mr. Mohit Kumawat for their valuable insights. Thank you so much, all of you.